Hello everyone, this is Siddharthan. Currently, we are discussing about the fourth module in our hands-on machine learning course with Python. So this fourth module is about data collection and data pre-processing. So in this data pre-processing module, this is the fifth video, which is on label encoding. Okay, so this is what we are going to discuss in today's video. Okay, so we will be taking two data sets and we will be performing this label encoding on these two data sets. So that is the objective of this video. So if you are new to this channel, in this channel, I'm making a hands-on machine learning course with Python. So this is my channel. So you can go to the playlist section of my channel, and in the first page, you can see this machine learning course curriculum video. So in this video, I have explained about all the videos and modules that I'm going to post in this channel. So in this description of this video, you will find this curriculum file. So you can download it and go through it. So you can also go to this playlist section. So these are the first four modules. So this module one is on the machine learning basics. The second module is on the Python basics for machine learning. And the third module is on important Python libraries like NumPy, Pandas, Matplotlib, Seaborn, etc. And fourth module is data collection and pre-processing. So the video which we are discussing also comes under this module. And I have also posted about 10 machine learning projects. So I will be posting 3 videos per week, and 2 videos will be on this particular course order, which will be posted on Monday evening and Wednesday evening, and I will be posting one machine learning project video every Friday. Okay, so that is about my channel. And you can also check this machine learning course with Python. So all the videos are incorporated in this particular playlist, so do check out. So we will be doing all the coding in Python and in this Google Collaboratory environment. Okay, so in Google Collaboratory you can run Python programs. So if you haven't heard about this, you can go to this Python basics playlist, where the first video is about how to access Google Collaboratory and how to know about all the features we have in Google Collaboratory. Okay, so with that being said, we can start with today's video. Okay, so label encoding. What is meant by this label encoding? So label encoding is about converting the labels into numeric form. Okay, so when we are working in a classification machine learning problem, so classification problems are nothing but we will predict whether a data point belongs to one class or the other. Say for example, we are predicting whether a person is diabetic or non-diabetic. So it is a classification problem whether in which we have to predict that this data points belong to one of these two classes. Okay, so if the data tells that that person is diabetic and non-diabetic, so it is not easy to use that value. So what we do is we convert the diabetic and non-diabetic these text values into numerical values as either 0 or 1. So this is about label encoding. Okay, so in this video I'll be explaining you how you can do that. So for this, I have taken two data sets. So the first data set, this data.csv, is a breast cancer data set, which is used to predict whether a person has breast cancer in benign stage or malignant stage. Okay, so benign means the starting stage of cancer, and malignant is more progressive and advanced stage of cancer. Okay, and this iris data set. So this data set is used to predict whether iris flower belongs to which of the three species. Okay, so in this breast cancer classification, we have two labels, and which are benign and malignant. In this iris dataset, we have three species of iris. So we will be encoding those labels. Okay, so you can find this connect option here. So you can connect the Google Collaboratory from here, and then you can go to this files option. So there you can give this upload to session storage option, or just right click here. So you can see this upload option. So I'll give the link of this dataset files in the description of this video. Okay, so first we are going to import the dependencies. So I'll just make a comment here about importing the dependencies. So we need two libraries. So import pandas as PD. So pandas library is very helpful to make a data frame. So data frame are nothing but structured table. So the dataset files which we have are CSV files. So CSV means comma separated values. So it is easy to analyze and process when we have the data in this data frame. Okay, and then we need a label encoder function. So we will import it from sklearn dot preprocessing import label encoder. Okay, so this label encoder function we will be using. So you can press shift plus enter to run this cell and go to the next one. So first we are going to encode this breast cancer data. Okay, so let's make a text as label encoding of breast cancer dataset. Okay, so the first step is to load the CSV file to a pandas data frame. So you can go to this options here and from there copy the path of this data.csv file. Okay, so now we are going to load the dataset. Loading the data from CSV file to pandas data frame. Okay, so I'll create a variable as, or let's name this data frame as cancer data. So cancer data, which is equal to pd dot read CSV, and we need to mention the path in the code. So I have already copied the path. So let's run this. So this will load the contents of the CSV file to a data frame. So now let's print the first 5 rows of the data frame. So first 5 rows of the data frame. So it tells us what are the different columns we have or different features we have in the data set. So cancer data dot yet. So this yet function will print the first 5 rows. So as we can see the first 5 rows here, so we have the ID for each data point and we have this diagnosis. This diagnosis is the label we have. So in this particular column diagnosis, we have two values as either M or B. So M represents malignant stage, which is the more advanced stage of cancer, and B represents benign stage or the starting stage of cancer. So if we can predict that the person has cancer in benign stage, so the probability is that that person will be saved because we can give the treatment early on. So this is the objective of this particular data set, but in this video our goal is just to encode this particular diagnosis column. So we have other features like radius mean. So these are the parameters of the cell. So this cancer cell will be analyzed using some test. So in this particular data set, this data is collected from a procedure called as fine needle aspiration, through which the cancer cells are obtained, and it is uh, used to do some test on it, and all these data are obtained. So these are cell data, the cancer cells data. So now we are going to uh, see how many data are there, or how many data points are there for malignant cases and benign cases. So finding the count of different labels. So we need to mention the data frame name. So here the data frame name is cancer data, and we need to mention the column name. So here the column name is diagnosis. So in the codes we need to mention diagnosis. Okay, so cancer data diagnosis dot value counts. So this value counts function will tell us the number of malignant cases we have and number of the benign cases we have. Okay, so I'll run this. Okay, so for benign cases, we have 357 data points, and for malignant cases, we have 212 data points. Now we are going to convert this benign stage and malignant stage into corresponding labels with numerical values. Okay, so first we need to load the label encoder function. Load the label encoder function. So as you would remember that we have imported this label encoder function from sklearn.preprocessing module. So let's create a variable as label encode, and in this particular variable let's store this function. So label encoder, and so we need to mention this parenthesis here to mention that we want to load one instance of this label encoder function to this particular variable. So I'll press shift plus enter, and now I'm going to encode all the labels to either 0 or 1, and I'm going to store it in a separate variable. So let's create it as label. Okay, so labels is equal to, so we need to mention this label encode, which contain the label encoder function. So label encode dot fit transform. So dot fit transform, and as I told you earlier, we are going to transform all the values of this diagnosis column, right? So we need to mention in this parenthesis about the data frame, which is cancer data dot diagnosis. So diagnosis, so this will take all the labels from this diagnosis column and it will convert all the values of M and B. Okay, so let's run this. So we will get a new column or new list which contain all these labels, and now we are going to append or join this labels value to another column in this particular data frame. Okay, so appending the labels to the data frame. Okay, so cancer data. So let's create a column named as target is equal to labels. Okay, so let's run this. Okay, so this will add a new column to our data frame. Now let's again print the first 5 columns. So cancer data dot add. Okay, so let's run this. Now you can see here at the last we have a new column called as target. So this is our target variable. So it says 1. So in the diagnosis we have 1. So all the values with m will be transformed with 1. Okay, so now we can drop this diagnosis column, and then we can do our predictions using these features and the target which we have made now. Okay, so in this case, so 0 represents benign. So 0 represents benign and 1 represents malignant cases. Okay, so we can also check the counts, value counts. So we have already seen how we can count the number of labels we have. So cancer data, we need to mention the target column, so which we are going to count dot value counts. Okay, so let's run this. And we can see here the label 0 has 357 values and the label 1 has 212 values. So you can just compare it with the previous one. So B, benign case has 357, malignant case has 212. So now you may get a doubt or that which particular label gets the label as a 0 and which label gets the value as 1. So because we haven't mentioned that malignant cases should get the value as 1 and benign cases should get the values as 0. So what happens is when you use this label encoder function, the labels present in that particular column will be arranged alphabetically. Here the two labels we have are M and B. So of course we know that B comes in alphabetical order at first. So this B will be given the value 0, and as M comes after B, so it will be given a value 1. So this is how we can do a label encoding on this particular breast cancer data. So the further processing we do will be to use this target and this feature to train a machine learning algorithm to make some predictions on whether a person has cancer in benign stage or malignant stage by going through these features. Okay, so we have already made several classification projects in our channel, so you can refer those project videos and you can make your project video. Oh, sorry, you can make your own project on this breast cancer based on those methods. Okay, so the next thing which we are going to do is encode using this iris dataset. So as I told you earlier, this is iris flower dataset and this contains 3 labels. So in this breast cancer dataset contains only 2 labels and this contains 3 labels. So it is the similar procedure which we have done. So I'll just copy the path from here. Okay, so we are just going to do the same thing. I'll just copy the code from here. So I'll just change the names. So now we are going to encode the labels. So label encoding of iris data. Okay, so let's paste the code here, and in this case we need to paste the path here and let's name this as iris data. So iris data. So let's copy the path from here and I'll paste it here. Okay, so let's run this. So this will load the iris data to a the CSV data to a Pandas data frame. So the next step are similar. So I'll use this yet function. So iris data dot yet. So this will give the first 5 rows of the data frame. So okay, so as you can see here, we have totally 1, 2, 3, 4, and 5 columns. So this is the species column, and this will act as the labels. Okay, so now we are going to transform this labels to numerical values as 0, 1, 0, 1, and 2. So 3 labels. Okay, So let's do the value counts function here. So iris data, and so the column name here is species, right? So you can see the column name as species. So let's mention it in quotes. So iris data species dot value counts. Okay. So okay, so something has happened here. So we need to mention the parenthesis. Okay, so we have 50 data points of for iris versicolor species and 50 data points for virginica and 50 species for iris setosa. Okay, so we have totally 150 data points, and now we are going to encode these labels. Okay, so it is the similar step, and let's load the label encoder again. Now let's so label sorry loading the label encoder. Okay, so let's create a variable called as label encoder 2. Okay, so the label encoder, the first label encoder we used is for the breast cancer data, and this is for this iris data. So let's mention the encoder function, label encoder. So I'll run this. Now let's create the labels and store it in the variable called as iris label. Okay, so iris labels is equal to label encoder 1 dot fit transform and iris dataset iris data dot species, because we are going to transform this species column. Okay, so you can see the column name here. So let's run this. Okay, so now we need to append it to our data original data frame. So iris data, let's create again a variable called as a column called as target, and in that we will store this iris labels. Okay, so let's run this and let's print the first 5 rows of the data frame. So iris data dot weight. Now you can see here. Okay, so something has happened here. Okay, so we shouldn't use this label encoder. So label encoder dot fit. Okay, so we need to fit transform. So we made a error here. So it should be label encoder dot fit transform. So let's run this again and this. Okay, now you can see here we get the target as 0. Now we can check the value counts function. So iris data dot iris data target dot value counts. Okay, so now we can see here we have 3 labels here, 0, 1 and 2. So now as I have told you earlier, so the labels will be arranged in alphabetical order. So here the first species that comes in alphabetical order is setosa, and then comes versicolor and virginica. So the label will be given the value 0 for setosa and 1 for versicolor and 2 for virginica. Okay, so I'll just mention it here in a text as iris setosa. The label will be 0, and for iris versicolor, so the label will be 1, and for iris virginica the label will be 2. Okay, so this is how you can take the labels from a data frame and you can convert it to a numerical value using the label encoder function that is present in sklearn dot preprocessing. Okay, so I hope you have understood how you can convert the labels into numerical values, and that's it for this video, and I'll see you in the next video. Thanks.